This is chapter 1. This is an introduction to the whole idea of geometry, and sections 1 is going to be built in here a little bit, but really we're focusing on section 2 and section 3 in chapter 1. So at this point, you'll need to have a section in your OneNote notebook labeled section 1-2, 1-3, and we're going to be able to put all of our notes in this one section. And what we're going to do here is be able to go through and define some of these terms. Please feel free to pause this at any point. Feel free to rewind if you need to rehear something, listen to something again, just review something, watch the video again as you see a diagram drawn if you've missed a little bit of it. And we'll go fairly quickly through these. I'm going to assume that you can rewind and rewatch this to be able to get most of the material. So section 2 and section 3 here, we're talking about the idea of introduction to geometry, and here we're talking about points, lines, and planes. And we're also going to be throwing in the idea of angles here. So the first term that we want to define here is equidistant. Equidistant, it says here, is defined as two or more objects that are equally distant from each other and or another object. So if we're talking about 2 points, it means they're the same distance from a given point as each other. So if we take a look at point A and point B and point C up top up here, if the distance from A to C is the same as B to C, say they're both 5 units long, then we would say that A and B are equal distant or equidistant from the same object, point C. There's a couple terms in here that we're not going to be able to specifically define in terms of exact finiteness. So we have these undefined terms, point, line, plane, space. The reason being is because we can't define how long it is, how thick it is, how wide it is. And so we need to be able to say what something is, how to describe it without knowing that it has a defined length of 5 units every single time. So the first thing we're going to talk about here is a point. It says here by definition, a point does not have any size, depth, width, or length. It's represented by a dot and named using a capital letter. So if I put down this point here and said this is point A, notice that we cannot define how thick it is, how deep it is, how wide it is, anything about it, except for it's a representation of a place on this screen. A line is similar, that it's undefinable, but we're going to try and give it some kind of parameters that we can talk about it with. It says it extends in 2 directions without ending, does not have any thickness, and is represented by a single lowercase letter or 2 points that it contains. So if we were to show you this, saying that it continues on forever and ever to the left and also to the right, we could name this by using 2 different things. We could label this with a lowercase letter L or N or M, or we could also label it using 2 points, point A and point B. So we could label this as line AB. Notice the notation above this shows that it continues in both directions to the right and to the left infinitely. And also we could also call this line L, as in lowercase l, because we've given it that name as well. The reason I say that these can't be defined is because we don't know how thick this line is, and the reason we don't know how thick it is because it uses points. Point A, which we set up top here, does not have a size, a depth, a width, or a length. Therefore, point A here and point B here are the same idea. They don't have any size, depth, width, or length, and therefore we don't have any size, depth, width, or length for our line here either. Please notice that the difference between this AB and this AB and this AB are all different. This right here represents a line. This represents a ray, and this represents a line segment. All right, so please make sure you use proper notation whenever you're describing something. If you want to label a line segment a defined length of that line, please notice that you only use this little notation above it. For a ray, you have an arrow on one side of it, because it's saying it continues on and on forever to the right or to the left. A line continues in both directions, so we need to make sure that we have it on both sides. A plane here is defined or suggested by a floor, a wall, or a tabletop. It extends without ending and has no thickness and no edges. It's represented by a capital letter or 3 or 4 of the vertices of the figure. Now, for our purposes, we're going to label it by 4 vertices rather than 3. 3 would only be if it's triangular, but most of the time when we talk about a plane here, we're talking about it being rectangular or square. And so we're going to label it by either 1 capital letter or by 4 vertices. And it says here a plane is suggested by a floor, a wall, or a tabletop. It's talking about a flat surface. But if you imagine with me, as you're sitting at home, your computer represents a flat surface. But you could continue the flat surface out farther to the left and to the right and up and down, and what that would do is now give you a bigger screen. Well, the idea of a plane is that all we're saying is we have this flat surface, and that's only the portion that we're seeing of the plane. There's really more of the plane that exists as it goes left, right, forward, and backward, but we're only seeing the portion of the plane that is the table. We could continue more for the left, farther forward, farther backward, and that would be still part of the same plane. It's just not represented to our eyes. Space here is defined as a set of all points, and so what we've done is we've kind of built here. Point, a single value, a single place on the table. A line is connecting two single points together and then continuing on forever and ever in both directions. A plane now says, okay, let's go even farther than that, and let's put 3 points that are all in the plane, or sorry, all on this table, but not all in a straight line. And now we've connected and made a triangle, or maybe we put 4 points down and we made a square. And then for space, we're saying, okay, we went from a point to 2 points to make a line, to 3 points that are not all in the same line to make a triangle. Now we have a plane. And then for space, we're taking one of these points that you can't see here on this screen, and instead of putting it here or here or here or here or here, what we're doing is we're now holding it above the computer, and we're saying, okay, that's the idea of space. We pulled it off that plane we were just drawing on, and now we're holding it up here in space. So to continue on with this lesson, look here at these next two terms, collinear and coplanar. Collinear says that it's points all in one line, and coplanar says it's points all in one plane. Now, when you come into class tomorrow, we're going to be talking about these more in depth, and I'll be having you guys working in groups and discussing these and giving examples of these, and you're going to work together to go through a couple activities that'll help you understand this a little bit better. So collinear says it's points all in one line, 1, 2, 3, 4, 5, 6, 7, and as long as these are all on the same line, they're said to be collinear. Now, if you had one point that was not on here, so say we had point H that was above this, wouldn't that be the idea of non-collinear? And coplanar points is saying points all in one plane. Now we're talking about points that are all on the screen. Point A, B, C, D, E, F, G, and H. They're all on this computer screen that you're looking at. But if we had one point that was not on the computer screen, we pulled it up above it, talking about the idea of space, that's the idea of non-coplanar. Now, we talked about some undefined terms that are a little bit more abstract. We can't really put definite values on them, but now we have some defined terms. And defined terms start out with the idea of segment, ray, opposite ray, length, and then we're going to talk about what postulates and axioms are as well. So the first one, let's talk about what a segment is. It's a portion of the line, and we talked about that just a little bit before. It has endpoints, and it's named using those endpoints. So if we talked about the distance from A to B, this is a segment because it has a defined length. In this case, it might be 5 units or 10 units or 5 centimeters. It has a defined value from A to B. We can't measure that for a line because it keeps going forever and ever and ever and ever in either direction. But a segment is only a portion of that line, and we can definitely define what that value is. We can definitely measure what that value would be. Array has one endpoint and extends indefinitely in one direction. So we're going to extend this one to the right. It passes through passes through point B. We'll call this ray AB. Notice my notation here that the arrow is pointing to the right, meaning it starts here at A and then passes through my letter B. That's a ray. Now, a ray cannot be measured either because it starts at a defined value, but then it keeps going and going and going and going and going forever to the right. So we can't ever measure it. As soon as we measure it and say, okay, that's 1 foot long, it adds a little bit more to it, and then now it's 1.5 feet, and now it's 3 feet, and now it's 10 feet, and now it's 100 feet, and it just keeps going forever. So the only one so far that we can measure is the idea of a segment. Now, opposite rays are two rays that share the same endpoint, but extend in opposite directions indefinitely. So if we have a ray, and we'll switch up the letters now, ray DE, and then it says, okay, it's a ray that shares the same endpoint, so they have to start at the letter D, and it's going to head in the complete opposite direction. Notice that they share this letter D in the middle. Okay, they share this letter right here, and because they share this letter in the middle, ray DE, notice my notation, and ray DF, they both start at the same letter, but head in opposite directions from each other. These are opposite rays, ray DE and ray DF. Now, length is the distance between 2 points. We talked about that before with the idea of a segment, and that's the only time that we can ever measure the length when talking about a line or array or a segment. Segments are the only ones you can measure the length. The distance from A to B to C, whatever letters you're talking about. And then the last piece we're going to talk about here in section 1, 2, and 1, 3 are postulates and axioms. They're statements that are accepted without proof. You're going to see these things throughout the book. You'll see postulates, you'll see theorems, you'll see axioms, you'll see definitions. Definitions are predefined by a group of people. Postulates and axioms are more those ideas that you think of. You don't need a lot of proof to go along with it, and therefore we can say, okay, well, that just kind of makes sense. That's a postulate or axiom. 2 plus 2 equals 4 is the addition postulate. And so what we can say here is that that's been defined by somebody else. They've proven that that works every single time. A postulate or axiom doesn't need a proof to go along with it. So the reason I share those two pieces with you is just so when you see them, when you see that name, it won't throw you off and you'll think, what in the world are they talking about? You'll understand that it's kind of the same idea as a theorem or a definition. It's used to prove something. It's used to help in your understanding, but we don't need proof to go along with it. So that concludes section 1, 2, and 1, 3. Hope to see you tomorrow.